Assalamualaikum warahmatullahi taala wabarakatuh dan selamat sejahtera. Chem Fullmark A, okay, Chemistry SK025 for 2016-2017, question number 5 to 8. Okay, tips menjawab soalan SK025 bersama saya, Madam Saria. Okay, now we look at question number 5, reaction kinetics. Okay, written as reacts to form products T and V at the constant temperature according to the following reaction. Okay, if you can see here, in an experiment, the data obtained was shown in table 1. So using integrated rate law method, plot a graph to prove that the above reaction follows second order. Calculate the value of the rate constant, half-life, and write the rate law for this reaction. Based on your graph, determine the concentration of S at 1500 seconds. So your given here is 10 marks. So what we need to do first, we need to find what is the input from the question, what is the output from the question. Output is something that the question asks you that you need to give the answers to get 10 marks. Alright? Okay, so we'll look at first. Using integrated rate law. Okay. Plot a graph to prove that the above reaction follows second order. So plot the graph is your output question number 1. Okay, so calculate the value of the rate constant, half-life, and write the rate law. So this is question number 2. This is question number 3. This is question number 4. And the last one, based on your graph, determine the concentration of S at 1500 seconds. So this is question number 5. Okay, so we decide first which one is input. Okay, input is something that give from the question that you can find output. Alright, so if you can see, using integrated rate law method. Okay, that's you have to follow. And then reaction follows second order. So what you need to do? So if you know this one is you must be using the integrated rate law method. So you kena tahu kat sini what is the graph that is supposed to be you use. Right? So reaction of course follow the second order. So second order. So what is the first you need to do? Plot a graph. Second, calculate the value. Rate constant, half-life, and rate law. And the third one, based on your graph, determine the concentration of S at 1500 seconds. Okay, so if you can see, this is a second order. You already know this is a second order. So you need to draw the graph using the integrated rate. Alright, so you know that from the equation, integrated rate equation. So you can see for the second order, 1 over concentration of A at a certain time minus 1 over concentration A naught equals to KT. So you need to draft Y equals to MX plus C. So it's become Y over concentration A at a certain time equals to KT plus 1 over concentration A naught. So this is draft. So this is your Y, this is M, okay, this is X, and this one is lintasan ya. Alright, let's see. So what you're doing here, so you can see 1 over concentration A at the certain time versus dengan times. So you can see the result is like this. So ini adalah 1 over concentration A naught. Right? So from here you predict what you need to do, you draft. You need to draft what you need to do using graph and using equation. Derived from the equation, right? Okay, so you need to plot the graph. Okay, the graph must has a title, label axis, and straight line. So from here, actually, you know that you need to find the 1 over concentration. So concentration, so you put in the value it is, you calculate first, and then you complete the table. So first, you need to complete the table. Complete the table. Okay, from here, you already complete the table, so you need to plot the graph. So the graph is as you sketch here. So this is supposed to be to get the linear graph, right? So you do that, you plot the graph. So it's like something like the graph must have a title, label axis, 1 over concentration S versus time. Then describe actually linear graphs are supposed to be straight line. Okay. So now we need to answer the next question, which is calculate the value of rate constant, half-life, and you need to write the rate law for this fraction. So if you can see, so now we need to find a rate constant using the second order. You already know this is second order. So you need to use the equation 1 over concentration S at a certain time minus 1 over concentration S naught is to KT. So you can see here from the table, you can see concentration at the certain time for 10 minutes is 0.32. Okay, and the concentration S at the 0 time, so it's a 0.22. Okay, you add from here, so you just get the input from the equation. So you can see, you can find the rate constant, and you have to remember that you need to add the unit, which is m minus 1 minute minus 1, right? Okay, now we need to find the half-life. So our half-life for second order is, you derive from the rate law, you can find half-life equals to 1 over K concentration S naught. Okay, you need to find half-life. So 1 over, so K you already get from the first question already, 0.01. So you need to find the concentration S naught. So you can see concentration S naught from the table, concentration of S naught from the table is 4.50. So 4.50, so you can find the half-life. And then the next question is, you need to write the rate law. So you already know this is the concentration. So this is the rate law for second order. Okay, concentration S, the power of 2. Okay, based on the graph, okay, you need to find concentration S. So if you can see the graph, okay, at the 1500 second, actually is 25 minutes. So you just dot to the graph, and then you can find what is the concentration it is. It is 0.470. This is actually for 1 over concentration as. So you need to find concentration as. So you can get 2.13 molar. So that's why you do the conclusion is concentration rating as at 1500 second is 2.13 molar. Okay. So you double check. Is that you answer all the question? First, you need to complete the table. Yes. You plot the graph, and then you follow all the rules for how to plot the graph. Okay, you calculate already rate constant, and make sure your final answer must have a unit. And then you find the half-life already, and make sure half-life also have a unit. And then last one, you find the rate law for this reaction. And from the graph, you determine the concentration S at 1500 seconds, and don't forget the unit of concentration. If you have done check, means you already finished for question 1, question number 5A. Okay? Now we go for question number 5B. Okay, actually this reaction is about reaction kinetics. Okay, in the reaction, the initial rate is 2.25 times 10 to the power of negative 3 molar, when the concentration of W is 0.33 molar. So if the reaction is a first order, so calculate the initial rate of the reaction when the concentration of W is 0.85 molar. Okay, given the rate constants for the first order reaction at 25 degrees Celsius and 35 degrees Celsius are 1.74 times 10 to the power of negative 5 seconds minus 1 and 6.61 times 10 to the power of negative 5 seconds minus 1 respectively. So determine its activation energy, EA. Okay, the next one is other than temperature, discuss two factors that would affect the reaction rate. So you are given here is 10 marks. Okay, as I mentioned before, you need to find what is the input from the question and what is the output from the question. So if you can see, the input is okay, initial rate. Input is something that have the value from the question, which is you have to start from the input to find the output, alright? Okay, so if you can see, initial rate already given. For the concentration, 0.33 molar. Okay, this is the first information. And this information actually, you need to find the you need to calculate the initial rate when the reaction 0.85 molar, right? So the second input is reaction is the first order kinetics. So you already know this is the first order reaction. Okay, this is the first order reaction. Okay, next. Okay, rate constant for the first order reaction is given at the different temperature with the different rate. So of course you need to find activation energy. So this is actually have the formula that you have to follow using the derived from the Arrhenius equation. So you dapat clue dah kat sini, oh actually this is Arrhenius. You need to follow the Arrhenius equation to get the answer. And the next question from the information is you need to discuss another two factors that would affect the reaction rate. Okay, this is actually you can get from the question. Okay, next. Okay, now you need to find rate. Okay, so you compare the rate 1 with the rate 2. Okay, so from here 2.25 times 10 to the power negative 3 already given from the input there, which is this is for 0.33 concentration. So you need to find for the rate 2. Okay, this is actually basically you come from the rate law. Rate equals to K concentration of W. But now you have a different concentration need to compare. So that's why you use comparison rate for the initial rate. Rate 1 over rate 2 equals to K concentration W over K concentration another W with a different rate. Okay, so actually kalau melibatkan initial rate, initial rate, ada dua kebarangkalian yang dia mungkin akan tanya you lah. Okay, the first one is maybe the data or the input is come from experiment, which is you are given the experiment data. So you need to find initial rate. You need to find order. Okay, but from this question, you already given the information. It's not from the table of experiment or whatever, comparing of experiment or whatever. So actually you are already given the value of rate 1 and the value of concentration. So directly you can find the initial rate for the second one. So that's why you can get rate equals to 5.8 times 10 to the power of negative 3 molar. Okay, done already. Don't forget to find answer to add unit for the final answer. Make sure you do this, alright? If not, you cannot get the mark for the final answer, even your answer is correct. Okay? Now we need to find the second question which is determines its activation energy. Okay, you already know from the information given from the question, which is this is actually first order. Okay, you need to apply Arrhenius equation. Actually, what is the Arrhenius equation? Okay, Arrhenius equation actually equation that relate rate with the concentration and with the activation energy. Okay, if you can see from the question, you already given rate 1, rate constant 1 and rate constant 2. So you are given also the different temperature. So you just using the formula ln K1 over K2 equals to EA over R 1 over T minus 1 over T1. And then you get the input from the question, you add it from here, and then you can get the answer EA, and don't forget the unit is kilojoule per mole. For the next question. Okay, the next question asks you, other than temperature, discuss two other factors that will affect the reaction rate. So, but before that, we'll discuss what is actually the factors that affect the rate of reaction. Okay, the first is temperature. The second one is concentration. The third maybe pressure, size of particles, and catalyst. Okay, I list down actually all the factors that affect the rate of reaction. But in this question, already mentioned that except from temperature, so you actually no need to discuss about the temperature. So I find here, and we'll discuss here is about concentration. Okay, so I choose concentration, so we'll discuss about the concentration. So when the concentration of reactant increase, the number of molecule per unit volume is increased. So what happens next? The number of effective collision increase, and the last one, rate of reaction increase. You have to remember that there is a requirement for effective collision occur. Okay, so you have to make sure reach the EA, which is the minimum energy required to initiate the chemical reaction, and also with the correct orientation. So after and then of course when the effective collision achieved, so occur, so number of effective collision will be increased when you increase the concentration, and the rate will be increased, rate of reaction increase. And the second one, I choose a size of particles. Actually, you can choose a catalyst if you want. Okay, so I choose from this question is size of particles. So when size of reacting particles are smaller, decrease, so the total surface area exposed for the reaction will be increases. So the reaction becomes faster. So thus the reaction rate will be increases. Right? This is actually same. Okay, it's same as if you can see, of course it's become faster means effective collision also, number of effective, okay, collision need to be increased lah. Okay, so the reaction rate will be increased. So this is actually factors. Alright, we already done for question number 5. Now we'll proceed for question number 6. Actually, this question is all about hydrocarbon. Okay, the question asks you, state two types of bond cleavage that occur in the covalent bond and explain how these cleavages occur and identify the species formed. So complete the following reaction equation by showing the movement of electrons using curved arrows. So discuss the bond cleavage involved in the reaction. So this equation is given to you, so you need to using this one to show the movement of electrons. So 12 marks given here. Okay, as I mentioned before, you need to separately what actually is your input and what is your output. So what is the input from the equation? What is the output from the equation? Actually, if you can see, this question is directly. So you just go for the output. Okay, state two types of bond cleavage is the first question. Explain how these cleavages occur. Second question. Identify the species form, the third question. Complete the following reaction equation by solving the movement of electron using curved arrow. Fourth question. Discuss the bond cleavage involved in the reaction. Fifth question. So means you have 5 questions to solve to get 12 marks from these questions. Okay, now we go for the first one. There is actually 2 types of bond cleavage, which is homolytic cleavage, hydrolytic cleavage. Okay, so done. And then you need to discuss this. So hydrolytic cleavage occur in polar covalent bond. Polar covalent bond, for example, if you have H and Cl. So you can see partially positive for hydrogen, partially negative for Cl. So you can see this actually is a polar covalent bond. So have a different electronegativity. So for the homo cleavage occurs in non-polar covalent. Maybe you can give the example. For example, Cl and Cl, chlorine. So these are partially negative, these are also partially negative. So if you can see the involving 2 atoms of the same or similar electronegativity. Okay, that the first differences that you can see, which is what is the difference between hydrolytic and homolytic. So if you need to discuss detail, so for hydrolytic, a single bond, if you can see here, break unsymmetrically, which is more electronegative atom will attract the shared electron to it, which is the shared electron stronger, and gain of the both of the shared electron means 2 electron will be given to chlorine, which is high electron negative ion. And you can see how's about homolytic cleavage. Okay, if you can see single bond from chlorine with another chlorine, break symmetrically because this one is similar in the electronegativity. So which attract the shared electron equally. Thus, each atom gain an electron. You can see one for you and one for me. Okay, so what is the product you can find here? Free radicals are formed. You can find Cl dot here. So 2 Cl dot will be formed here. If we give chlorine molecule as example, okay? So for the hydrolytic cleavage, you can find the product U is H plus, which is cation, and Cl minus, which is an ion with 2 electron gain. Alright? Okay. So this is actually answer question number 1 and question number 2 and also question number 3 from the explanation just now. So now we go for question number 4. Complete the following reaction equation by showing the movement of electron using the curved arrow. Discuss the bond cleavage involved in the reaction. So this is for question number 4 and question number 5. Okay, if you can see question number 4 that we are given here. So I need to show the arrow. Actually, hydrolytic, the bond cleavage occurs in HCl, which is this actually hydrolytic cleavage. Why actually this is hydrolytic cleavage? Because H is a partially negative and Cl is a partially negative. So as this here is a polar covalent bond. Okay, so the bond break, the chlorine actually is more electronegative. Okay, chlorine is more electronegative atom than hydrogen. So it will be attract the shared electron stronger and gain both of the shared electron. So you can see this arrow to show that chlorine gain the electron. Okay, so the bond break unsymmetrically to form H plus and Cl minus. Okay, cation and anion. So the lone pair from the nitrogen atom of the ammonia molecule species, actually it is have the empty orbital of hydrogen, thus to form. So this one will be attack H. Okay, it's become ammonium ion. It's become NH4 plus. Okay, so this is how actually you need to show the arrow, and this is how you need to explain the formation of the breaking bond using the hydrolytic cleavage. Okay, so if you can see the question, discuss the bond cleavage involved in the reaction using the showing of movement of electrons. Okay, so now we look at question number 6b. Alkenes are unsaturated hydrocarbon and chemically more reactive than alkene. Okay, this is the statement. So you have to know that alkene, unsaturated, chemically more reactive than alkene. Okay, the next is treatment of an alkene Y with halogen acid HBr gives Z. Okay, so if I read this question, so supposed to be we need to draw, sketch, um, what actually question relate from one another one. Okay, so kalau you tengok kat sini, treatment of alkene Y with halogen acid HBr gives Z, Y hydrogenation of Y forms AA, reaction of Y with reagent of BB give butanol and ethanoic acid. Okay, if you can see, treatment of an alkene Y with the halogen acid HBr, I tak boleh buat lagi equationnya because we don't know actually alkene is how many carbon actually. So Y hydrogenation of Y from AA also, with actually it is not the input. It's not the keyword that you need to start to find the structure of this question lah. Okay, but if you can see this statement, reaction of Y with reagent BB give butanol and ethanoic acid as the product. Okay, from here I dah boleh lukis dah butanol and ethanoic acid. So starting from this, actually you can find also from the BB, you can find AA, you can find Z, you can find what actually is Y. Okay, inilah kunci dia. Okay, key. You find the another structures. Okay. So, kita tunjuk lepas ni. Explain the reactivity of Y. Determine the type of reaction involved. Draw the structure of Y, Z, AA and identify reagent BB. Show the isomerism of Y. Okay, we go one by one. Explain the reactivity of Y and determine the type of reaction involved. Okay. Y tadi, as you can see from the question, dia dah mention itu adalah unsaturated. Dia adalah alkene. Okay, alkene is reactive compared to alkane. Why? Sebab dia ada carbon-carbon double bond. Carbon-carbon double bond ni dia ada sifat dia adalah electron rich side. Okay, nucleophile side. So, the pi bond than the sigma bond. So, dia akan exposed to the electrophilic attack. What is the meaning of electrophilic attack? Electrophilic attack, which is nucleophile, will be attacked electrophile. So you add electrophile for this reaction. Any of electrophile for react with Y. So therefore, Y undergoes electrophilic addition reaction. Okay, for example, you have R double bond R, for example. You plus with electrophile. You know now, so R actually a double bond or alkene, or let's say this is Y, for example, is an electron-rich species. I can see that this double bond will be attacked as a nucleophile attack E+. So it's become single bond. It's become single bond here. And you can see from the double bond become a single bond. This one is addition reaction. So because you add electrophile here, so this is actually electrophilic addition reaction. Okay. Okay, the next question is treatment. As I mentioned before, so I cannot do for this question because we know that Y actually is alkene. React with HBr to get Z. Okay, so this is the first question that I give you. I don't know what is the structure of Y, so how I can get the Z structure? So that's why we'll proceed. They said that hydrogenation of Y. We know Y. Y of course we know which is alkene. react with hydrogen gases, okay, which is have a platinum as a catalyst. For example, you can use a nickel or palladium. You need to choose one only. Okay, so you can get a AA, but still I don't have the clue for this. But you go for the next one, reaction of Y with BB. Okay, so reaction of Y, which is alkene, with the reagent of BB, you can get here is butanon. 1, 2, 3, 4. Okay, this is butanon. And plus ethanoic acid, CH3, CH, C double bond O, OH. So this adalah ethanoic acid. So you can get from here is butanon. This one is a butanon. This one is ethanoic acid. Okay. If you can see these structures, you can see this structure. Reaction of Y with the reagent BB give butanon and ethanoic acid. Recall back the reaction of alkenes. There is two reaction of alkene which is can get this structure, but which is oxidation reaction. Oxidation reaction of alkene we have two. This is oxidation using strong oxidizing agent, for example KMNO4H plus 18. And another one is using the ozonolysis, ozone as a reagent. But if you can see the signal here as a product, that here is ethanoic acid, not aldehyde or ketone only. So if proceeds to ethanoic acid, means this is not using the weak oxidizing agent, for example, is ozone. So this is actually oxidation using the strong oxidizing agent. So means the product, the reagent BB is a strong oxidizing agent. So which is KMNO4, H plus, and heating. Okay, this is actually BB. This is actually BB. So so what is alkene get? Okay, if you can see actually for the oxidation reaction, they will break the double bond. Okay, so you just sambung je kat sini. So you get product is CH3, C double bond. Right? CH3, C double bond. So you can see the rest of that is CH2, CH3. Another one, carbon here for this one. So this carbon has another CH3 as a neighbor. Okay. Okay. Okay, I delete this one. It look like double bond here. Okay, we go for carbon that bonded with CH3. So this actually is CH, CH3. So actually this is the structure of Y. Okay, using KMNO4, H3O plus and heating. Okay, this is the condition and the reagent, so you can get the product. Okay. Okay, so because kalau you break this double bond, if you break double bond, you akan dapat this structure, which is butanon. Okay, R and R, there is no hydrogen, so no need to oxidize to form the carboxylic acid, whatever, because actually this is secondary. If you can see this double bond, so it's become a ketone. So it's one because of when you oxidize, you already have another hydrogen here. So you need to proceed for the oxidation because it's a strong oxidizing agent. So you can get the ethanoic acid. Okay, so this is the structure of Y, this is structure of Z, this is structure of AA that we already discussed just now. Okay, tadi kita dah bincang, kita dah dapat structure untuk apa sekarang ni. Okay, kita dah dapat structure untuk BB, alright, dan kita dah dapat structure untuk Y. So kita boleh pergi ke atas ni lah. Okay, sebab kita dah tahu dah what is our alkene kan. Okay, bila kita dah tahu dah apa kita punya alkene, CH3 bonded with, okay, I letak CH2, CH3 kat sini. Okay, so if you can see alkene kita, so CH3C dekat, alright. So this back, CH3 bonded with carbon, which is have CH2, CH3. Okay, this is for, okay, CH3 bonded with C double bond. Okay, so I will do correction here. Okay, so this is not double bond here. Okay, this is actually double bond here. This is come closer. CH3, C double bond. Okay, this is your alkene already. CH3. Okay, when you do hydrogenation, you know that when alkene do the hydrogenation, so you can form alkene actually. So CH3, C that have the CH2, CH3. So double bond, you focus double bond, you just add hydrogen here, and another double bond, you just add another hydrogen here. So this is the structure of A. Okay, now we go for the first one. Lagi sekali sama juga Okay, you punya ni adalah CH3, CH2, CH3, double bond here, so CH3. This is your structure of alkene. So you add HBr. Okay, this is actually follow the Markovnikov rules, which is for the addition of H hydrogen must be added at the carbon double bond carbon that have greater number of hydrogen. So if you can see this carbon and another carbon or that which is have a double bond. So this carbon actually have hydrogen. So supposed to be hydrogen must be add here and Br must be add here to follow the Markovnikov rule. So it's become CH3, CH2, CH3. So single bond. So you add here is Br. This one is CH2 and CH3. So this actually structure for Z. Okay. Z dah dapat. Y dah tahu. Y tadi Okay, hydrogenation of Y. Actually, Y tadi adalah alkene tadi. Kita dah dapat AA. Kita dah dapat BB. Kita pun dah ada kat sini BB. Kita dah dapat tahu dah BB tu apa. Okay, done. So, this is all the structure Y, Z, AA from this question. Okay, the next question is you need to identify and show the isomerism of Y. Show the isomerism of Y. So how we need to show the isomerism of Y? So we know that Y is the alkene. So of course the stereoisomerism for alkene actually adalah cis-trans isomerism. So if you can see this structure of Y, follow the requirement for the cis-trans isomerism occur. Which is if you can see this structure for cis isomer. So this is CH3 will be this is also CH3. So ini at the same side So this is cis and for the same requirement pertama adalah carbon-carbon that have resisted rotation must have a different atom. This is requirement kedua They have the different atom or molecule attached to it. So actually this follow. And also for the trans isomer. So actually this is follow the cis-trans isomerism. Okay, done for question number 6. Okay, done for question number 6. Okay, so the next question is question number 7. Benzenes and its derivative. Compound CC is formed from the reaction of benzene with CH3Cl in the presence of AlCl3. Okay, so the first one you need to get. CC is formed from the reaction of benzene in the presence of AlCl3. Oxidation of CC with the reagent TT produce EE. Okay, the second one. The first one is really the second one. Okay, the third one is chlorination of CC in the presence of light give FF, the third one. Whereas reaction of FF with methoxide ion produce GG, the fourth one. Okay, the question asks you, such as structural formula of CC, EE, FF, GG, and give reagent DD. Okay, ini yang you kena set the problem lah. Okay, so from the laluan tadi lah, 1, 2, 3, 4, so you get this one. And the next one is propose all the reaction involved in the initiation and termination step. Okay, dia nak 2 step saja. We know that it's involved for the free radical substitution reaction involved 3 steps. So actually the question only asks for initiation and termination step only for the chlorination of CC to FF. And the last one is in the reaction that convert to benzene to CC and write the mechanism in box. So 30 marks given here. Okay, compound CC is formed from the reaction of benzene with CH3Cl in the presence of AlCl3. So it can see. So this is benzene. Okay, this is benzene. So react with CH3Cl. Okay. Okay, using the catalyst AlCl3. Okay, what you can get from, this is Friedel-Crafts alkylation because we use alkyl light and we use the Friedel-Crafts catalyst. So what you can get from here, so you can find here the substitute one of hydrogen here with CH3. So you can find here, you can get alkyl benzene plus HCl. Okay, so compound CC is alkyl benzene, which is methyl benzene. So it's become methyl benzene, atau nama common name dia adalah toluene. Okay, this is actually toluene. Okay, done. You already get the structure of CC using the Friedel-Crafts alkylation. Okay, the next one is oxidation of CC with the reagent of TT to produce EE. Okay, so what is the structure of CC kita tadi? Ia adalah toluene, right? So kita ambil toluene kita balik. CH3 tadi. Okay, kita campur dengan reagent. Okay, kita campur dengan reagent kita sekarang ni adalah DD, but we don't know what is actually DD. So kita akan produce kat sini EE. Kita mention kat sini ini adalah oxidation. Kita mention kat sini ini adalah oxidation. So oxidation of alkyl benzene menggunakan apa? Okay, you boleh pakai kat sini. Barangkali DD adalah KMNO4, H3O+, and heating. Okay, so ataupun you boleh pakai K2Cr2O7, and heating. Okay, so ini DD. So daripada kita tahu dah oxidation of methylbenzene ataupun alkyl benzene, you akan dapat benzoic acid. So COOH. Okay, COOH. So ni adalah EE. Okay, so actually EE. So you already get EE and TT. Okay, the next question is chlorination of CC in the presence of light give FF. Okay, kita go back. What is the CC tadi? Okay, CC kita tadi adalah alkyl benzene. Mention balik. Okay, so alkyl benzene kita tadi CH3. Okay, you campur dengan chlorine with the presence of light UV. Okay, sekarang ni kita letak dalam CH2Cl2 or CCl4 lah. So because we already know actually this is halogenation. Okay, so it's the product. So they akan substitute one of the hydrogen. So you will form here is CH2Cl. Okay, you akan dapat CH2Cl plus dengan HCl. Okay, for this case. Okay, for this case. So actually this is the structure of FF. Done already to find the FF. Okay, reaction of FF. Apa tadi? CH2Cl, FF. Okay, so you ambil balik tadi reaction of FFU, which is CH2Clu. Okay, actually ini FF. You react with CH3O minus. Okay, if you can see, when you react with the CH2, actually this is reaction of haloalkane. So you just refer to the CH2Cl. Okay, so in this is when you react with the CH3O minus, actually you will form ether. It will be formed ether. So CH2O CH3. Okay, this is supposed to be your product. Okay, so this actually is GG. Okay, so I mention balik what is the CC, what is the EE, what is the FF, what is the GG, and what is the DD. Alright. Okay, the next question is propose all the reaction involved in the initiation and termination step for the chlorination of CC to FF. Okay, you need to propose all the reaction involved. Okay, and termination step from the CC. Okay, CC kita tadi apa? So we'll recall back. What is actually our CC? CC kita adalah toluene. Okay, CC kita tadi toluene. Okay, so kalau untuk chlorination plus dengan Cl kan, chlorination. Jadi kita ada first step iaitu chain initiation step. This is actually chain initiation step. So apa yang perlu ada pada chain initiation step? You will just focus to the halogen that we use. So we have chlorine and another one chlorine. So if you need to provide energy, light energy will be provided for the hydrolytic cleavage occur. One for you, one for you. This is for the homolytic cleavage occur to form free radical. So you form here is 2Cl free radical. This is for initiation step. Okay, this is actually for initiation step. So now we go, okay, actually for it is the first step. The second step is supposed to be propagation step. But the question just only mentioned here is initiation and termination step only. So you just go for the chain termination step. You just follow the question. Chain termination step. Okay, what is the chain termination step here? So you just go for the all the free radical involved here. So Cl dot plus another one Cl dot. So 1 and 1. So you get here is Cl2. Another one is from the propagation step tadi, you sebenarnya tadi kalau ikut propagation step, you pakai CH3. So from the CH3 ni dia akan dapat CH2Cl actually. They replace one of the hydrogen with Cl. So what is the another free radical that you can form from here, which is you akan form another free radical is CH2 dot. Okay, so from here, maksudnya walaupun soalan tak minta propagation, tapi kalau nak dapat penjelasan yang jelas, so you boleh buat, you boleh guna propagation step juga sebenarnya untuk cari what actually the result you can get. Okay, so what is the product form here? So you can get here is, okay, you pakai CH2 kat sini kan, dot another one CH2. You can see that another one CH2 that bonded also with benzene. Dia jadi macam ni lah. CH2, 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 another one. Okay, this is actually for termination step. So another one is switch. So CH2 dot plus dengan Cl dot actually free radical sikit kat sini. So you can find one is CH2Cl. So this is for termination step. Okay, name the reaction that convert benzene to CC and write the mechanism involved. Okay, benzene tadi, the first question. Okay, the reaction ni So what is the name of the reaction? Ada kata tadi namanya adalah Hydrocarbon alkylation. So you answer from this question is okay, so what is the name of the reaction is Hydrocarbon alkylation. Okay, dah name dah. Okay, so write the mechanism involved. So what is the mechanism involved here? What is the mechanism involved here? Okay, untuk question for the graph calculation, you have 3 steps. Okay, you have 3 steps that you need to follow. The first step is formation of electrophile. Okay, formation of electrophile. So kalau you tengok structure you tadi, you need to use reagent and catalyst saja kat sini. Reagent and catalyst. So what is the reagent that you use from here? So you pakai tadi CH3, Cl. Okay, you nak kena plus apa? Cl3. Okay, so Cl3. So this, what happened next? So this will be at here. So it's become CH3, Cl, bond here, Al, Cl3. So this one is become positive, this one is become negative. Okay, actually you form here is a complex. Okay, you cannot get the electrophile from here, but you can get from the second step for the electrophile. Okay, so for the second step adalah formation of arhenium ion. Formation of arhenium ion. Okay, how to find the formation of arhenium ion? Okay, you just ambil balik you punya benzene. Just now. You nak kena tunjuk H dia because you need to substitute this. Okay, kalau boleh buat dalam bentuk, you need to write in, have a double bond. It's not the calculus structure. You have to follow this. Okay, so I erase this one to show where is actually the double bond have. Okay, so this is double bond from here. Okay, I mention double bond kat sini lah. Okay, kat sini and kat sini. Okay, so bila you plus dengan you punya complex tadi, so CH3, Cl, dot, 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 dot. Okay, ada plus tadi. So, which is dengan Al, Cl3 minus. So, what you can get here. So, this double bond, which is have a high density of electron from the pi bond. So, it's at that CH3. So, this bonding between this will be at that plus. Okay, it's become like this. So, you kena follow arhenium ion. So, kat sini, I tunjuk macam mana nak follow from the next step. Okay, this is from the next step. So, what happened? So, you akan go for arhenium ion. Okay, kita go for the first one, arhenium ion, which is the next step tadi. Bila dah join, dia jadi apa Okay. So, tadi kita letak double bond kat sini. So, if you can see just now, kita letak hydrogen kat sini kan. Okay, this one akan masuk H. Okay, dan akan masuk CH3 plus. CH3 kat sini, so plus di sini. Okay, kalau you tengok double bond yang lain, I tak usik. I tak usik double bond ini. I tak usik lagi double bond ni. So, I just usik double bond ni. Okay, see this double bond will be replaced. Okay, this double bond will be replaced untuk yang positif tadi. So, dia akan ada satu lagi resonance structures. So, it's become, okay, H still lagi ada kat sini. Okay, so double bond become here. So, this one is become positive balik. Yang ni I tak usik Okay, so yang ni pula akan backup for positive. Alright, so it's become double bond dah ada. Okay, so it's backup here. So it's become double bond here. Double bond here, double bond here. So this is still lagi H and CH3. So this one is positive. And dia akan sentiasa berlaku secara repetition. Repeat lagi sampailah seterusnya. Okay, but don't forget at this time juga sebenarnya dia keluarkan AlCl4 minus yang kita keluarkan tadi daripada atas ni. Kita ambil CH3 plus from here, kita ambil CH3 plus kan. Okay, so kita ada selebihnya lagi adalah AlCl4 minus. Okay, so from here. Okay, yang you buat ni sebenarnya ini adalah arenaceous ion. Resonance from the arenaceous ion. Okay, barulah you follow for the next step, iaitu step 3. Okay, if you can see step 3 adalah loss of H+. Okay, di mana you akan keluarkan H+ ni. So, I ambil the last one. You boleh pilih mana-mana satu. So, I choose the last one. So, jika I draw the last one, so kita ada sekarang ni adalah H dengan CH3. So, we have double bond here, we have double bond here, and we have plus here. So, apa yang kita nampak nanti, kita campur balik dengan AlCl4. Sebelum ni lah. Okay, kita tunjuk sikit lah AlCl. Okay, ini adalah AlCl3 minus. AlCl4 minus Okay, kat sini ada lone pair. Tunjuk sikit. Okay, kita tunjuk sikit adanya lone pair. Okay, padam sikit yang ni supaya nanti dia tak confuse. Yang mana dot, yang mana okay. So from here, what actually you get here is this bonding will give to chlorine. This one will be at that H. This bonding will go for this one. So what is the product you get here is, okay, you can find the product now is become CH3 double bond here. Okay, I make it clear. Okay, padam sikit. Okay, plus dengan HCl plus dengan AlCl3. Okay, so this is step to write the mechanism for Hydrocarbon alkylation. Okay, for Hydrocarbon alkylation. Okay, now we go for question number 7. Still, if you can see, this is actually benzene and its derivative. Okay, 1 chloropropane react with the KCN in ethanol under reflux to form HH. Reduction of HH produces JJ, while hydrolysis of HH using aqueous acid under reflux gives KK. So, Grignard reagent of 1 chloropropane react with ethanol to form LL. So, show the formation of the Grignard reagent. Draw the structure of HH, JJ, KK, LL, and write the chemical equation for the formation of JJ and LL. Banyak ni. So, that's why kita fokus satu-satu. Okay, dia kata tadi, 1 chloropropane react with KCN. Okay, kita keluarkan satu-satu. In ethanol under reflux to form HH. So, kita ambil kat sini CH3, CH2, CH2, Cl, which is 1 chloropropane. Okay, react dengan KCN. Okay, dia react dengan KCN. Okay, I tulis kat sini. Dia react dengan KCN plus dengan KCN. Okay, ini hydroalkane punya reaction ya. CH3, CH2, CH2, CN ni dia react dengan KCN in ethanol. Okay, dalam ethanol and then you need to reflux. So, it's the product that you can get. Letak bawah ni tak muat. So, you nak form HH sekarang ni. So, you just replace a substitute Cl with the Cm. Ini adalah nucleophilic substitution reaction ya. So, you can get CH3, CH2, CH2, Cn. Okay, nampak tak beza dia? Dia just substitute saja. Okay, the second one yang you dapat ni sebenarnya adalah HH nama dia. HH. Okay, the next one is reduction of HH produce JJ. Okay, reduction of HH produce JJ. Tadi HH kita apa tadi? Nitrite. Okay, CH3, CH2, CH2, Cn. Ini daripada HH tadi Ini kita punya HH tadi Okay, daripada HH tadi kita nak buat reduction. Okay, bila kita nak buat reduction, kita boleh pakai reducing agent lah. Okay, apa reducing agent yang kita boleh pakai kat sini? Okay, apa reducing agent yang kita boleh pakai kat sini untuk this question? Okay, so first kita mungkin boleh pakai lithium aluminum hydride. Okay, I bagi choice kat sini Apa reducing agent yang kita boleh guna? Okay, pertama you boleh guna lithium aluminium hydride. Okay, ini followed by hydrolysis. Pertama. Yang kedua, you boleh pakai hydrogenation dengan adanya platinum ataupun nikel ke ataupun palladium. Okay, yang ketiga, you boleh pakai NaBH4 dengan adanya methanol sebagai reducing agent. Okay. So, you pilih lah. So, I nak pilih lithium aluminum hydride. Followed by H2O. So, nak buat apa kat sini? Ini sebenarnya preparation of amines. So, you just daripada carbon ni letak hydrogen. N ni pun letak hydrogen. So, it becomes CH3, CH2, CH2, and H2. So, you dah produce JJ. So, sekarang you dah produce JJ. Okay, the next question is hydrolysis of HH. Still lagi dia nak guna nitrite. So, CH3, CH2, CH2, Cn. So, dia masih lagi guna HH. Okay, tapi dia buat hydrolysis. Okay, dia campur dengan water dengan adanya H+. Okay, kita tahu ini adalah preparation of carboxylic acid. Ini adalah preparation of carboxylic acid. So, macam mana kita nak form? Okay, macam mana kita nak form from here? So, you just recap. From here is CH3, CH3, CH2, CH2. So, how's about Cn? Cn ni dah jadi C double bond O, H. So, this is actually structure for KK. Okay. So, pregnant of reagent of 1 chloropropane react with the ethanol to form. Okay. So, actually, what is the pregnant? Show dulu formation of pregnant tu. So, macam mana kita nak show formation of pregnant? Okay, daripada chloropropane. So, CH3, CH2, CH2, Cl. Okay, dia akan campur dengan magnesium untuk form pregnant dengan adanya triether. So, it can form CH3, CH2, CH2. Cuma dia separatekan saja antara R dengan halogen. Dia masuk tengah-tengah jadi MgCl. So actually yang you form sekarang ni adalah Grignard reagent. You form sekarang adalah Grignard reagent. So tadi dia kata show the formation of Grignard reagent, and you have to use this Grignard reagent to answer this question. Okay, so Grignard reagent you tadi CH3, CH2, CH2, okay, Mg, kita pakai Mg tadi, MgCl. So MgCl. So this is your Grignard. Okay, Grignard reagent or 1-propane tadi, you reactkan dengan ethanol. So you campur dengan CH3, C double bond OH. This is actually ethanol. Okay, to form LL. Kalau kita tengok selalunya, kalau kita nak ambil daripada Grignard menggunakan aldehyde or ketone, sebenarnya dia ada followed by lah. Di mana kat sini you akan ada dry ether, and then you followed by hydrolysis. And then you followed by hydrolysis actually, H2O dan juga H+. Okay, what you have to do is, okay, dia akan cut kat mana sebenarnya? Dia cut kat sini. And then yang ni dia akan double bond, is become single bond because ini adalah addition reaction ya. Double bond is become single bond. So it become product dia C macam ni. Kalau kita nak draw, kita ambil yang aldehyde dia ni. Kita buat macam ni. Yang lain kita tak usik. Okay. So O dia kita tak usik. Kita ambil dia satu bonding double bond ni, kita turunkan kat bawah. Okay. So apa yang berlaku adalah water ni ada H+ dengan OH-. So H+ akan ada di sini sebab O- akan tarik H+. So OH- from here akan bawa lari MgCl ni. So ia akan ambilkan MgOHCl. So kat sini akan ada carbon kan. So kat R ni lah yang akan, daripada Grignard ni lah yang akan masuk CH2, CH2 and CH3. So this is actually LL. This is actually LL because you can form here is a secondary alcohol from the ethanol. Okay. So as a conclusion, untuk draw structure of HH, JJ, KK, LL. So this is all the structures yang supposed to be you get, right? This is all the structures supposed to be you get. Okay. So tadi dia kata write the chemical equation for the formation of JJ and LL. Okay, kalau tengok kat sini, dia nak suruh formation of kepada LL. Okay, di mana you punya formation tadi untuk Grignard reagent adalah from the JJ kepada, okay, kita tengok from the JJ nak pergi kepada LL. So tadi kita dah tunjuk equation lah. Okay, daripada Grignard. Okay, for this question Grignard reagent macam mana daripada JJ nak form LL. So dia followed by saja. So mana kita cari JJ kita tadi? JJ kita daripada CH3, CH2, CH2, NH2. Okay? Okay, now kita go for this question. JJ kita tadi adalah CH3, CH2, CH2, okay, CH2 and H2. Alright? Ini JJ kita. CH2 and H2. Dia dah cut sebenarnya. Sebenarnya dia boleh datang daripada nitrite. Okay, tadi kita kata tadi kita daripada JJ nak hasilkan LL. Betul tak? Okay, first tadi kita buat apa tadi? Untuk hasilkan JJ tadi. Okay, kita ambil tadi CH3, CH2, CH2 and H2. Betul? Betul tak? Okay, so sekarang ni Grignard reagent of 1-chloropropane react with the ethanol to form this one. Jadi kita kena form dulu hello alkene. From here, hello alkene plus KCN, you akan form kat sini HH. So from the HH, you buat reducing, you akan dapat JJ. You akan dapat JJ. Okay, so from here daripada JJ, daripada HH, you akan form KK. So last one, you akan form LL. So sebenarnya kalau ikut equation kita dah lengkap kita dah buat lengkap daripada equation sehingga dapat yang ni. Okey. Untuk keseluruhan JJ and LL. Okey, dan sebenarnya kalau ikutkan kita dah buat all the equation. Kita tak buat yang ni lah. Okay, now the last question is question number 8. About amines, amino acid and polymers. Okay, show how would you prepare aniline from benzene. Aniline react with the acidified sodium nitrate at 5 degrees Celsius to form MM. An addition of phenol to MM produce NN. Write the chemical equation involved and draw the structure of MM and NN. Provide a significant physical feature and use a compound of NN. Okay, kita separate satu-satu. Show how would you prepare aniline from benzene. Okay, so you nak kena show. Macam mana you nak prepare aniline from benzene? Sorry, aniline from benzene. Okay, this is actually benzene. You nak form sekarang ni adalah aniline. Adakah boleh form directly? Okay, ini aniline. Ini adalah benzene. Boleh ke form directly? Tak ada kan? Benzene tak ada reaction untuk form directly to aniline. Jadi, kita tahu preparation of amines atau aromatic amines, dia mesti datang daripada nitro. One of the preparation adalah nitro. So, nitro ni boleh buat tak? Benzene boleh buat tak? Okay, so that's why you direct pergi kepada yang ni. Okay, yang ni menggunakan nitrous acid. Artinya, H2SO4 concentrated, both is concentrated. Both is concentrated. Okay, 50 to 55 degree Celsius. So, you akan dapat nitro. So, nitro kepada ini adalah menggunakan reducing agent. You boleh pakai hydrogen dengan adanya platinum. Okay, kalau kita tak nak pakai hydrogen, kita boleh pakai apa lagi untuk this case? Okay, atau you boleh pakai followed by stannous dengan adanya HCl followed by OH minus. Okay, atau you juga boleh lagi pakai zinc, OH minus dan seterusnya lah. Okay, so saya buat gambaran keseluruhannya adalah di sini. Okay, you boleh pakai stannous, boleh pakai zinc dengan adanya HCl dan OH minus untuk form this one. Okay, so ini untuk write the equation involved yang kita discuss tadi for this case. Alright, so aniline react with the acidified sodium nitrate. Okay, yang ni adalah preparation tadi lah. So how you prepare aniline from benzene. Dan sekarang ni aniline react with the acidified sodium nitrate at 5 degree to form MM. Okay, MM tadi saya dah tunjuk formation of MM di mana kita pakai nitrous acid, adanya HCl dan dia adalah suhu 0 to 5 degree Celsius, you akan dapat diazonium salt lah. So ini adalah diazonium salt. Okay, N plus triple bond N, Cl minus. Okay, this is actually for MM. Okay, the next question asks you is an addition of phenol to MM produce NN. Okay, for this case, you ambil NN, ini adalah application Ini adalah diazonium salt because it's a very unstable species. So you campur dengan phenol, what you can get actually dia berada pada para condition para position. So daripada this one you jadi single bond, you just focus here. Yang lain-lain you just copy, yang ini saja yang berubah. So it become N double bond N. Right? It's become N double bond N. Alright, so ini adalah application to form dye actually. Ini adalah application to form dye. Okay, so ini untuk MM and N. So disuruh write the chemical equation involved. So kita dah write. So draw the structure of MN and NN. Dah draw. So ini structure MN, this is structure NN. So disuruh provide a significant physical features and use of compound NN. NN ni dia ada intense color lah. Dia ada intense color. So bila dia ada intense color, dia actually commonly used as a dye. Sebenarnya apa? proses application untuk amines. So kalau tengok application amines yang paling menyeluruh industrial adalah kenapa? Ya, sebab exo compound yang kita tahu ini adalah intensely colored. Satu. Dan dia sebenarnya relatively inexpensive compound. Dia sebenarnya adalah inexpensive compound. So banyak guna dalam industri lah. That's why kita guna dia sebagai pewarna. Dan kalau you perasan yang kita hasilkan sekarang ni, bila kita campur ni, dia adalah orange colour sebenarnya. Dia ada satu lagi yang kita form dengan another structure. Selain daripada yang ni, kita juga boleh guna kita juga boleh guna CH3 and CH3, dan dia sebenarnya sama saja, perbezaannya di sini ia akan ganti dengan yang ni. So itu sebenarnya formation of yellow colour. Okay, so ada dua lah yang kita boleh apply kat sini untuk dye for examples. Okay, the next question is for question, this one actually question number 8. Sorry, this one is question number 8. Ada error kat sini. This one actually question number 8. Okay. Isoleucine to amino 3-methylpentanoic acid is an, okay, this one is all about amino acid. Okay, isoleucine is an essential amino acid. Draw the structure of isoleucine and also its structure at pH 2, 12 and pi. So give the product form when the isoleucine react with the ethanol in the presence of hydrochloric acid as a catalyst, and name duration. So 6 marks will be given here. 6 mark will be given here. Okay, sekarang ni kita draw dulu apa sebenarnya structure isoleucine. Isoleucine 2 amino 3-methylpentanoic acid. Okay, pentanoic acid 1, 2, 3, 4 and 5. Okay, so ada 3CH3 at the carbon number 3. At the carbon number 2 you have amino, and this one is C double bond O, OH. Okay, you complete that, CH3, CH2, CH and CH. Okay, so ini adalah daripada IUPAC nomenclature tadi. So inilah sebenarnya isoleucine. Ini adalah isoleucine. So this isoleucine pula dalam keadaan pH, kalau kita nak draw dia dalam keadaan pH equals to 2.0. So ini dalam pH acid acidic medium. So ini dalam keadaan acidic medium, you kena kekalkan yang mana menunjukkan acidic properties. Ini kan? Okay, so ini wajib adalah. Alright, so you akan form kat sini CH3, CH2, CH. Alright, this one is CH3. Ini kita tak usik CH. Okay, C double bond O pun mesti menunjukkan acid properties. Yang beza kat sini adalah dia akan form NH3 plus here. Ini pada pH 2.0. So kalau pada pH 12.0, okay, dalam keadaan basic. Ini dalam keadaan basic medium. So you kena tunjuk yang mana menunjukkan basic medium. Adanya NH2. Betul? Okay, yang tu kena kekal lah. So you can form CH3, CH2, CH. Okay, I tunjuk kat sini CH3. CNH2 tu tak berubah apa-apa. Saya menunjukkan basic properties. So kat sini ada CH dan ini adalah C double bond O dan juga O. So, itu menunjukkan dalam keadaan basic medium. So macam mana pula dalam keadaan PI? Okay, dalam keadaan PI dia mesti ada dua-dua lah untuk balance kan. Sebab dia punya zero charge, dia adalah neutral dan have a zero charge. Alright, so the structure is CH3, CH2, CH and CH3. So this one is CNH2, CH, C double bond O, O minus. Actually ini adalah NH3 plus. Okay. Alright. So soalan seterusnya, give the product form when isoleucine react with ethanol. Okay, kita ambil isoleucine kita tadi. Apa isoleucine kita tadi? CH3, CH2, C, yang ada CH3 kat atas dia, CH, C, ada NH2. Okay, so So you have another one. C double bond O. Sorry This one C double bond O OH tadi. Okay, you reactkan dia dengan ethanol. CH3 CH2OH. Kalau you tengok ethanol ni, bila dia react dengan ethanol, the presence of ada pula sebagai acid as a catalyst. So nampak sangat ini adalah esterification process. Ini adalah esterification process. So dia kata name the reaction. So the reaction is esterification process. Ataupun esterification reaction. Okay, ini esterification reaction. Okay, so dia akan form kat sini, dia akan buang OH from the acid and dia akan buang H from alcohol. So it's become, okay, ini structure dia. Okay, yang ni semua dia tak kacau. Yang dia kacau kat sini, C double bond O, OH dah buang. So dia terus bonded pada O yang ada, letak ke bawah CH2. Sorry, I tak muat jadi I ke bawahkan dia. So inilah yang you form sekarang ini adalah ester. So yang you form sekarang adalah ester. Okay, so question number 8 again. So if you can see question number 8, masih lagi amines, amino acid and polymers. You nak kena differentiate between the terms repeating unit and monomer. Give the repeating unit and monomers of polymer QQ ni. Okay, so 6 mark will be given here. So apa sebenarnya repeating unit? Repeating unit is the portion of molecule that repeat itself in the polymer. Okay, so yang you nampak sekarang ni, ini adalah polymer. So apa repeating unit dia? Okay, tak apa, nanti kita go through. Okay, inilah repeating unit sebenarnya. Inilah repeating unit. Okay, ini sebenarnya you nampak repeating unit. Dia tak ada N lah. N dah jadi polymer. Kalau N bilangan dia repeat banyak kali, so it's bigger size. So itu dah jadi polymer. So repeating unit adalah dia repeat benda yang sama daripada monomer. Okay, so what is the monomers? Monomers ni pula adalah small organic compounds that can be covalently bonded to each other in repeating patterns. Okay, so apa beza pula dengan monomers? Okay, kalau you tengok kat sini, apa monomers untuk yang ni? Okay, kita ada dua monomer lah yang wujud kat sini. Okay, kalau tengok ada dua, ini adalah copolymer nampak ketarik dengan copolymer yang datang daripada addition, condensation. Addition, polymerization. So you akan dapat kat sini, okay, this one kat sini kan single bond. So bila masuk untuk monomer, dia is become double bond. You tak ubah apa-apa pun sebenarnya. You tidak mengubah apa-apa. Ataupun terus buat CCl2. Ini struktur yang pertama. And okay, struktur yang kedua adalah CH2 double bond CH and Cl. Ini saya selalu sengaja kembangkan Ini saya sengaja kembangkan supaya you nampak jelas lah. Okay, you nampak jelas di mana sebenarnya yang patut kita highlight ini Cl. Cl saya tampakkan jelas sikit. Kita tarik tadi. Okay, ini Cl. Okay, ini adalah monomers for polymers QQ tadi. So datang daripada addition, polymerization. Kita ada dua condensation dengan addition, polymerization. Oleh kerana pada kes ini dia tak eliminate apa-apa dan daripada berbond jadi single bond. So this is become addition, polymerization structures. Okay, itu sahaja untuk discuss question number 5 till question number 5 till question number 8 untuk past year's question 2016-2017. Okay, dengan yesterday is history, tomorrow is a mystery, you don't know yet, right? So today is a gift of God. So you hargai apa yang you ada sekarang, which is why we call it the present. Okay, that's all from me, from Madam Sarah. Bye.